I'm Brian from Deska, and I'm here to talk to you guys about structural issues. Just to give you a little bit of background here, Deska is a structural engineering contracting firm. We diagnose, design, and repair solutions to structural issues. Can we have this show up here as well? Seems like we have it backwards. Perfect. Okay. We're located right here in Alexandria. We specialize in structural repairs, foundation repairs, and waterproofing. It's just a list of our licenses and specialty certifications. So we're going to go through some case studies with some symptoms, the actual issues behind the symptoms, and then the solutions as well. And then at the end, we'll go through some diagnostics and kind of do some quizzes, some practice, and then Q&A. But if anyone has any questions in the meantime, feel free to speak up. To start here, we have static forces review. Here are your general static forces, and by static meaning nothing should be moving, or at least should be moving much. We have tension up in the top left corner, compression here. Let's see if I can. Yeah, we have tension here, compression here. We have torsion, and we have shear, and we have flexural as a beam. Just to kind of give you an example of each. Tensile forces would be an example, would be a rope, right? It's very strong in tension, but it has virtually no other strength to it at all. You're not going to push anything with a rope. Compression, columns are typically the most common member in compression. Torsion, that could be an axle or something. There aren't a whole lot of members in say a residential home that have torsional forces. Shear forces, an example of shear would be screws or nails, bolts, or the ends of a beam are in shear. And with a beam or with bending stress, you have a tensile stress on one side and a compressive stress on the other. And that allows it to bridge whatever you're trying to span. There we go. Okay. Just some more examples of that. We'll cruise through this here. So we're going to start with foundation walls, and in terms of how they move and potential issues with them. We'll start with some of the symptoms that you'll see. You'll see horizontal cracks in foundation walls, vertical cracks, stair-step cracks, shear cracks down there at the bottom, and then also you have water intrusion as well. So we have some, as you can see in the top two pictures here, we have some stair-step cracking, and these are typically due to differential settlement of a foundation. And if you look carefully at the crack, if you were to put a trend line on that crack, it can give you an idea of what might be going on. Usually when you have a stair-step crack, you put the trend line in, that gives you usually a diagonal orientation of the crack. And there's the crack slope there. And you'll see that the low side of that trend line or that crack slope is the side that is typically settling. Not always, but that's generally the case. On the other picture here, same thing, but the opposite direction. The front side would be the side that is settling. Down below here, we have some horizontal cracking. This is typically due to inward deflection of a foundation wall. The wall opens up like a hinge from the soil outside pressing on it. Usually it's related to drainage issues as well. When the soil gets saturated with water, it puts a lot of pressure on the foundation and pushes in these unreinforced block walls. They don't have any steel reinforcement in them. They're not really designed to deal with much of a lateral force up against them. Here's some more examples of that. The inward deflection leading to the horizontal crack, and then usually at the corners, it's stair steps where it meets the perpendicular wall. That wall is helping to brace it. here's some examples where the inward deflection of a foundation wall, it's one of the few structural issues where you actually see the symptoms somewhere other than the wall that's actually having the issues. In this case, you'll see two side foundation walls of a home that have a crack in them near the front corner, but it's actually not the side wall that's bowing inward. It's actually the front wall of the house that is bowing inward. And what happens is, because the front wall is pinned at the bottom and it's bowing inward, it actually pulls outward and causes a crack like this to occur. So if you're ever at a house like this doing an inspection, what you really want to look at would be the front wall, the wall to the left here, as opposed to the wall with the actual crack in it. If it's finished and you can't see it, well, I mean, I would recommend removing the drywall typically, or having an engineer come out to look at it. We can only say what we can see. So this is an example of this as well. You have your two little cracks at the front right and left corners. And if you were to be standing on the inside of the home looking towards the front of the house, you would actually see something that looks like that. Or if we looked at an elevation view, if you were inside the house looking at that front wall, that's textbook what you would see: a long horizontal crack, and then where it meets the perpendicular walls that are helping support that wall, you get this stair-stepping effect. Obviously, this can happen in a lot of different ways, but that's kind of the textbook look of that inward deflection. You can put a 4-foot level on it, and you can see how the wall is bowing inward. The 4-foot level will typically seesaw on the crack. Also, if you don't see a crack, sometimes you may just see that the mortar joint is a little bit thicker than the others, and that could be the sign of that some repair has happened in the past. And so it's definitely something you'd want to look into. This is another example of the same thing, except it's actually on the exterior above the wall. You have the kind of the inward hinge of the wall at mid-height, and then this is kind of the opposite, the equal and opposite pivot point of the wall above grade, where it causes in this case, the brick facade to separate to allow for that movement. Here's a couple other examples of that. In the top left one here, there's some cracking there, and you can see that giant tree right next to the wall. That's definitely contributing to it. And on the inside as well, you can see that the wall has bowed inward. And if you look at the bottom here, excuse me, the bottom right picture here, you can see that there's some shearing, essentially the blocks sliding on top of each other. That's kind of the progression of that inward deflection. Typically, the cracks are first. The next step is the shearing and the blocks sliding on each other. That's typically a little bit more serious, and the repair methods actually change once you have shearing. So if you have shearing, that's definitely a serious issue. Here's an example of a way to stabilize the wall from an inward deflection situation. These are carbon fiber straps. There's numerous manufacturers of these. In this particular area, the manufacturer has to be ICC certified. It depends on the building official in your particular area in terms of what they will accept or not accept. But this is a good standard here. They get anchored at the top and the bottom, and they prevent that inward deflection. However, once the wall is sheared, these are generally not an appropriate solution. So if the wall is bowing inward, you can use these. They're the most cost-effective, efficient way to do it. They're also only about 1/8 of an inch thick, so it doesn't eat into your basement area. You don't lose any square footage when you install these. So they're an excellent product, and they're code compliant. This is an example. The top two pictures here are an example of what it actually looks like in real life. They're not pretty, but you can paint over them, and you'll just see kind of white strips or whatever color you decide to paint the wall. You'll also notice that when a wall is strapped, all the mortar joints must be retuck pointed. If they're not retuck pointed, the wall can actually go back in. If say the soil shrinks on the outside of the wall can actually bow back outward potentially, and it would damage the straps. The straps would be like rope. They're very, very strong in tension, about roughly 5 times stronger than steel, but in compression, they have virtually no strength at all. It's almost as flimsy as rope. Another potential way to deal with the shearing aspect is you can actually do what we call shear pinning, which is where you actually core the face of the wall, install steel reinforcement in the wall, and then grout it and fill it with concrete, essentially. That's another option. Obviously, you would have preferred to do that when the foundation was being built. To do that after the fact is much more time-consuming and expensive. Also, you don't know what kind of debris is in the wall from when they built the foundation. If there's all kinds of trash and insulation or who knows what in the wall, you may not be able to get the rebar where you need it to go, and the same with the concrete. So it's a little bit of a guessing game. So we generally don't recommend the shear pins. Another option here is steel struts. They're essentially steel beams, typically installed vertically on a foundation wall, and again attached to the top floor structure and the bottom, typically the footing, and they usually have their own footings as well. This is typically how they're designed. You have a footing at the bottom, it's attached to the floor structure at the top, and then because the beam is straight and plumb, and the wall is bowing inward, you have gaps besides that, say the farthest point of inward deflection. So then we typically recommend grouting that area so you have a nice continuous support throughout the wall. And this is really what you'd want to install. If the wall is sheared at all, you really want to have these steel beams. They're more expensive than the carbon fiber straps. So ideally, carbon fiber is recommended unless you can't use it. So if the wall is sheared, you'd want to use these, and they're designed to be able to withstand that shear force. Here's an example of what they actually look like, and as you can see at the bottom here, you can see that there's a gap that has been grouted with cement, and as you come up the wall, it disappears, and as you get to the top of the wall, usually it will widen again. So they're not the ugliest thing in the world, but you'd prefer not to have them in your basement, obviously. And they typically eat up 4 to 6 inches of space too. So, if you can get away with carbon fiber straps, that's ideal. These are more expensive. And if you have a 30-foot wall and you're going to lose 6 inches, you just lost 15 square feet of your foundation there. So you can finish over this, but your wall is going to have to sit in a little bit farther. Here's another example of a wall that's sheared inward. In this particular case, you can see it usually happens more so at the bottom where the soil pressure is greater. And you can see where this level is here. It's about 3 inches, 3.5 inches off that wall is how much that wall is bowed in. And you can see up in the top right picture here, you have a vertical crack. As opposed to the stair step that we were talking about earlier. It's not always perfect, but yeah, that vertical crack was caused by that inward deflection of the wall bowing, and not just in kind of the y-axis, but actually in the x-axis along the wall. In this particular case, the wall had to be stabilized. The wall had to be stabilized laterally as well as vertically. So a lot of the strength of the wall actually comes from the floor structure sitting on top of the wall. If you're sitting in a chair and someone tries to push the chair out from underneath of you, it can be pretty difficult. If no one's sitting on the chair, there's no weight on top of it, it's much easier to kick that chair out. So when you temporarily brace the flooring vertically, you're actually doing the wall a disservice because you're taking a lot of that weight off the top of the wall. So in this particular case, the wall needed to be stabilized laterally, and the floor needed to be stabilized vertically as well. This was going to actually be a wall replacement, but actually we were able to excavate it out And instead of replacing the wall, actually push the wall back straight again, install steel struts. And while it was all excavated, the owner figured it was a good time to put in an egress window. So you can see you have your steel struts there, and then they're framed around that window. So the owner didn't take too much of a beating, as they were able to add some value to their house as well. Here's an example of a foundation wall where a waterproofing contractor came in to install an interior drainage system. They either didn't realize or didn't care to notice that the wall was showing signs of distress and bowing inward. And after they jackhammered out the concrete slab, the wall collapsed inward like this. If you look down in the bottom here, you can see where the slab was removed, and then there wasn't much supporting the bottom of the wall. So the slabs are generally not structural, and the slabs generally are not supporting the bottom of the wall. But if the wall is failing, sometimes they will accidentally, if you will, be laterally bracing the bottom of the wall. So you have to be careful about that. Another method of stabilizing inward deflection of wall is wall anchors. Essentially, you have a wall plate here, and you have a tie back or a threaded rod that goes into the ground, and then you have an earth plate here, and then a certain amount of torque is applied to the tie back, and it stabilizes the wall. Can potentially straighten the wall if you torque it during drier seasons when the soil shrinks. And if you're going to do that, you have to leave that joint open. But we generally don't recommend this type of repair unless it's kind of a last resort. We prefer not to be bracing a lateral wall with the soil that can move and expand and contract depending on a lot of external factors. Here's an example of what they look like on the interior of a basement foundation. Here's an example of a staircase, an areaway that you can see has a lot of water issues. The exterior perimeter drain at the bottom is not functioning, and the water is pouring through the wall. In this case, it's a double brick wall, so you're very limited to how you can actually stabilize that. In this case, this was a full replacement, and to bring it up to code and put the proper drains in to relieve that pressure. Here's an example of a foundation wall in Arlington that just completely collapsed. As you can see, it was about 26 feet of foundation wall on the left side of the house, which was the entire left foundation wall. And it's as you can see, it's a load-bearing wall, obviously by being an exterior wall, but in addition, the floor joists rest on it as well. In this particular case, what we surmise saved the house above was that little cripple wall there that someone at some point had installed to support a staircase that I guess had some sagging or settlement issues. And without those 4 or 5 studs there, that probably would have completely collapsed. The whole house probably would have. Here's another example here of a wall failure. Usually as opposed to the last slide, usually when the foundation walls fail from lateral inward deflection, usually it's not the entire wall at once. Usually it's in isolated areas like this. And it's in terms of how it actually collapses. But this particular wall had to be replaced. I think it was about 25 feet or so when you include the two faces. Here's another example of a wall that just bowed in too far, it needs to be replaced. It should really have lateral bracing, temporary lateral bracing there as well. But in this case, the owner just had a contractor come in and put vertical bracing until it could be replaced. Here we have an example of a foundation wall where the exterior wall above it is actually a masonry wall as well. It's I believe it went from 12-inch blocks to 8-inch blocks with a row of bricks on it. And the problem that you run into with this type of wall is that in order to remove the wall, you have to temporarily brace the masonry wall above it, which is extremely heavy. There's a couple floors above this. And you can't, many walls you can just support the floor joists and they will support the floors above it. In this case, the floor joists are in beam pockets and they're not meant to support the exterior walls above. So what has to be done is before the wall can be removed, these what we call needle beams need to be installed through the wall at certain spacing to support the heavy wall above it. And once these, you'll see there's a column and you have a beam that goes through the wall. There's a column on the other side of that wall as well. And if you look at the exterior picture here, you can see where the wall is completely removed and solely the needle beams are supporting it until the new wall can be built. And the new wall would be a reinforced wall with steel reinforcement and grouted to prevent that from happening again, as well as, of course, an exterior drain tile that relieves that water pressure on the wall. This is actually same foundation wall, just finished, and you can see from the outside, everything is back in place like it should be. Just needs paint. Sure.
You do the underpinning yourself, or you sub it out?
So we as a company, it's all in-house. We don't sub anything out. Are you referring to underpinning or wall replacements or both? Any of it?
Either one.
Anyway, yeah, we do. It's all in-house. We don't subcontract anything. Yeah. Well, it varies by the length of the wall. If it's I think in this case, I think it was about 20 feet or so, and I think it was about $40,000 to do that. Yep.
You had mentioned bring up the code.
Mhm.
So are you required to, when you make a repair, say like on a 1940 house, to make that kind of adjustment that wasn't, quote, grandfathered in, but you have to bring it up to current standards?
In terms of a wall replacement?
Or you used it earlier in another context, but just in general, however you want to respond.
So generally, if you're replacing something with new, it needs to be brought up to the newer code. If it's a repair, then that can be a little bit different. But ideally, I mean, the building code is the minimum. So ideally, even if it wasn't required, we'd want to bring it up to at a minimum, the building code. But yeah, if it's a replacement, pretty much every building official requires it to be brought up to the new code. Yeah. And I mean, you can actually, even today, you can still build a foundation wall out of hollow blocks. There's certain height restrictions and fill restrictions. But I mean, as an engineer, I like to be conservative, and we would always install steel reinforcement. I mean, we'd want to have it better than it was before, and we don't ever want to have to worry about it again. Usually these are caused by drainage issues. If 5 years from then the owner forgets to clean their gutters and it's draining water next to this wall, we don't want to have the issue again. It doesn't add that much more cost to it to grout the wall and put steel reinforcement in it. So you just do it in a way that, yeah.
So Brian, let me interrupt for just a minute. If I could remind people that there are actually more people online than there are in the room, and they paid the same price you did. So we'd like to include them, which is why there are microphones on the table. So if you have a question, if you could turn on a microphone and speak into the microphone, that way I don't get all these messages like this that say I can't hear the question, please.
Right, yeah, the question was, does it need to be brought up to the new code? If you're replacing something, generally it needs to be brought up to the new code. If you're repairing something, the original structure doesn't necessarily need to be brought up to the new code, but the repair does need to meet the code. So when you're talking about steel struts, the steel beams, when you're talking about carbon fiber, they are, like, for instance, carbon fiber is ICC certified, and the counties will generally, the building departments will generally check to make sure that whatever you're doing is ICC certified, or it'll go through an engineering review to make sure they find it acceptable. Sure.
Once I figure out how to use it, if it's on, if it's not on. Sorry.
Do you grout the cavities where you have the steel reinforcements?
Absolutely, absolutely. Yeah.
Okay, I got it working now, or I got, someone help me. My question is, some of these photos are pretty dramatic looking.
Mhm.
So what prompted the repair? Was it a home inspector that saw something that triggered a further evaluation, so to speak? Or is this after something already failed? Or I'm sure you have a little bit of both, but what generally gets you to a job site to figure out how to go about all these repairs?
Yeah, so it's a variety of things can happen. And this one in particular, it was a finished wall in a basement, and a waterproofing contractor went in to install an interior drainage system. And when they went to do that, they saw the condition of the wall after they removed the drywall, and they just said that they couldn't help them anymore. So they told the owner, "Hey, can't help you." The owner called an engineer, and then the engineer called us to go out and take a look at it. So the wall hadn't failed yet, condition where it couldn't be salvaged. Here's an example of a foundation where the footing is just about floating. And the footing obviously is what transfers the load of the foundation wall and the entire structure to the earth. And so if you have a void below the footing, that's really not good. That can be a pretty urgent situation. And in this particular case, you can see there's some undermining there, caused by, again, drainage issues. The house is on a steep hill. And you can see the measuring tape here. I think it went in about 2 feet underneath that footing. And above that, you can see that's a poured concrete wall, which is extremely heavy. So this needed to have piers installed on it. And in this case, we had to install temporary helical piers on the footing. When we install push piers or helical piers, before you can do that, you generally have to jackhammer and notch the footing so you can get the pier underneath the wall. We felt the situation was so dire and dangerous that we didn't feel comfortable jackhammering the footing because the vibration could cause the structure to fall or collapse. So we installed helical piers on that ledge of the footing to stabilize it in place, and then we proceeded to underpin the actual foundation. This is actually the same foundation, but on the inside. It's an area below a garage. There's a concrete slab, and there's some minor cracking in it. The slab is not structural, but the slab had settled a couple inches towards that area where the undermining was. And after removing the slab, we found a sizable void below there as well. So the drainage issue was just causing all of the soil to erode out from below the footing and the interior slab. So just because these cracks in the slab, they're not a structural concern, but they often kind of point to a larger issue. And just keep in mind, you can only say what you can see. There's a lot of things you can't see. So kind of going back to like the inward deflection of the foundation wall, sometimes you can only see a little area, and the basement's finished. Maybe the soil is too high on the exterior. You can't see much, but sometimes just these little symptoms can turn out to be a big problem. So I'd always just be very aware. Here's an example of a large tree that fell, just missed the house. Obviously, if they hit the house, that wouldn't be ideal, and they would have had some bigger problems. But the concern here was actually that because the tree roots had pulled out so much of the soil, that it may have pulled out some of the soil from below the footing, causing a potential settlement issue. In this case, it didn't. They were pretty lucky. They just needed to have the tree removed and hauled away, and then backfill the area. Yes.
Hey, Brian. Okay. As home inspectors, what we get taught for concrete slabs is concrete's gray, it's hard, and it cracks, right? And so we see cracked slabs a lot, especially in basements. At what point would you recommend to say, hey, this is something that we should pay closer attention to and need to refer to someone like yourself versus, yeah, this is the normal cracking we see. Typically, for myself, I do if there's a deflection between the height and the crack, or if it's significantly wide, right? What would you say to us as the inspectors? Like, okay, this is a point in which you need to refer to someone else on.
Yeah, so yeah, I mean, in this particular area, probably 95+% of the slabs are not structural. Now, I mean, I wouldn't just go into every home inspection thinking that, but I'd be aware of that. If you have a lot of cracks in the foundation slab, I would probably maybe just be, a little bit more careful at other areas. You see cracking in other places, maybe the slab is structural. Also in a basement, if you look closely at, say, at a block wall, so usually the bottom row of blocks, you won't be able to see a full block here. Usually you'll see a half of a block or a couple inches or 1 inch. And that would tell you that the wall keeps going down into the ground to a footing ideally. Now, if you see a full block, then there's a chance that the wall may actually be sitting on top of the slab, in which case the slab would be structural, could be, or I should say could be structural. You could have what's called a monolithic footing, which is where the slab is built down around the perimeter of the foundation and is actually structural. But if you're seeing large cracks in the slab and the slab is structural, you're probably going to see other warning signs as well. So if you only see cracks in a slab and you can see, say half a block, not a full block at the wall, then more than likely it's not structural if you don't have any symptoms. But if you can see the full block or you can't see it at all, but there's a lot of cracks in the slab and you have cracking in the walls or areas above, then I would treat it a little bit more seriously. And, I would say I'm conservative. I would say play it safe and definitely note it. Yeah. Here's an example of someone who dug out a basement and they dug below the bottom plane of the footing. It's a big no-no. What can happen is that soil can essentially almost mush out like a marshmallow if nothing's retaining that soil. So what needed to be done was the footing needed to be built down, or what we call traditional underpinning, where you extend the footing down to a proper bearing soil that's been inspected. Typically, before the footing can be poured, an inspector has to come out, probe the soil, make sure it's suitable, and it meets the design requirements of the footing. In this area, it's 1,500 pounds per square foot, but it varies depending on where you are, and also if you have a geotechnical investigation, you can use a different standard as well if it's determined to be adequate. We have deep foundation underpinning. These would be helical piers or push piers. Essentially, they're piles that either get hydraulically pushed into the ground as push piers, or helical piers, giant screws that are screwed into the ground. Push piers are installed just using a vertical hydraulic force downward, using the weight of the building, and typically a safety factor of 2 is used. So if the particular pier needs to support 10,000 pounds, you drive it until it can support 20,000 pounds, and then you attach it to the building. Helical piers, they go by torque. When they get screwed into the ground with the machine, the torque is consistently measured until it meets a certain torque value, and that torque value actually correlates exactly to the vertical capacity of the pile. Again, a safety factor of 2 to 2.5 is used for helical piers to support a footing. Here's an example of helical piers getting screwed in this case with a small excavator. This is a building in Northeast where had some settlement issues. So the piers were screwed in and then they get bracketed to the foundation. And then in this case, these are about 20-ton jacks go under each of the brackets, and they can apply an upward force to the building and either stabilize it in place or potentially lift it depending on what the goal is. Here's just a kind of a detail of what helical piers look like, and you can see how they attach to the footing there as well. Here's an example of a chimney that's leaning away from a house. You can see some pretty sizable stair-step cracks there. And as you look up the chimney, you can see that the separation gets wider as it goes up. Chimney's settling and then in turn leaning away. For chimneys, usually ends up being 2 helical piers. And it's very important that they're installed one at a time, because to install a helical pier, you have to undermine the footing. And a chimney footing in this case is probably 4 feet by 2 feet. And if you were to undermine enough for 2 helical piers at the same time, there wouldn't be much supporting it. So the chimney could actually collapse or fall away from the house. So 2 helical piers were installed individually, one at a time. And then we had some custom steel brackets made to go around the chimney to help pull it back in and secure it as well, and tie that into the floor structure.
Do those typically right the settlement or just stabilize it?
So generally stabilization would be guaranteed in terms of if it will move or not. It's hard to say. If someone has repaired it before and they filled the void, then it's not likely it will move. Or if, let's say, when it pulled away, debris fell into that void, you're not going to be able to move back into place. If it's like a newer separation, then usually it will go back into place. But if it's been there a long time and who knows what's gotten in there, if just a few pebbles or some debris, a piece of wood is stuck in there, you're not going to have much luck pushing it back without damaging something. Steel lintels. So something that you guys might see quite often is steel lintels above window and door openings. When they corrode, they expand. We call it steel lintel corrosion expansion. And you get these little, you can see how in this case, the steel lintel is actually sagging, not due to the weight of the structure above or the brick facade, but just because it's expanding so much and it's not able to push up on the facade. And then typically it will cause the mortar joints next to the opening to crack. That's the beginning sign of that expansion, is when the mortar begins to flake off on both sides of the corner of the window. Only gets worse unless you do something about it. In many cases, if you clean them and you paint them and you have it retuck pointed, you can salvage them and you may be fine. But if they're unattended, once it begins to expand, that's usually about it. And they need to be replaced. So usually it's not really considered a structural issue if it's just supporting a brick facade. But a brick facade is very heavy. Although it's not supporting the structure, it is still very heavy and it is being supported. If it was, let's say, a full masonry wall, then it would definitely be considered a structural issue. But it only gets worse over time, like many things. And at some point, if it gets to the point where it needs to be replaced, the facade may never recover cosmetically from that. Once the bricks and the mortar joints have moved or expanded, you can put a new lintel in, but the mortar joints will still be thicker and it will still look funny. The mortar may not match well. There's a variety of cosmetic issues. So the earlier you can address it and resolve it, the better.
Had one of those a couple of weeks ago in DC. The rust expansion, it had pushed enough to set some stair step cracks up from the top two top corners.
Mhm.
They didn't want to replace the lintels. They wanted to tuck point it and try to stabilize it that way. I think that was a big error. But when's the call? When do you make the call as to this lintel has to be replaced rather than we can maybe fix this?
Yeah, so if the, if it's just that the mortar has flaked off and the lintel is visible, I would say you can definitely just have it, scraped, sandblasted, cleaned and painted again, and then remortared. If it's a hairline crack, I could understand going for that. Once it's separated and it's already causing, noticeable cosmetic damage, I would say it's too late. I mean, you really, it's already expanded, it's already corroded. I mean, you could remove the 2 rows of bricks above it, pull the lintel out, clean it up, and then reinstall it. But at that point, you might as well just put a new lintel in. Most of the work is in the masonry and getting it out.
On that point, do you have just a general feeling for a typical cost to replace a lintel like that one? It's pretty typical 36-inch piece of steel.
Yeah, so it really depends on height would be one example. If it's 30 feet up versus if it's 8 feet high, it's a big difference in cost. And then also how many. If you walk through Old Town Alexandria, DC, some areas in South Arlington, you walk down the street and you see this on almost every house, or every fourth house you'll see this. So if you're doing 10 of them at once, it's going to be much less expensive than if you're just doing one. If you're just doing one, it's probably some minimal mobilization charge from a masonry contractor. So whatever that is might be $1,000, $2,000, $3,000. But if you're doing 10 of them, it might come down to $500 each or something like that.
When you replace the outer lintel, do you often or not have to replace the inner?
So usually not, usually because it's a little bit more sheltered from the elements being on the inside. But when the exterior one is removed, and you can see it, if it's corroded, then we would make that recommendation. And sometimes there isn't one. If it's full masonry, there would be one. If it's timber frame stud wall, then you would only have an exterior lintel. Yeah. And also, depending on the type of construction, sometimes they should be flashed as well and have weep holes above them to prevent any moisture from building up behind the brick facade. But that just depends. So something that can also happen from those steel lintels expanding is, they apply a very powerful force upward on the facade, or in this case, these are full masonry brick walls. And if the wall is too heavy, or let's say there's 3 or 4 stories above it, the lintel, it's not able to lift that. So what ends up happening is the wall buckles outward, has nowhere else to go. And so then the wall bulges outward, and then it creates a lateral deflection issue, kind of the opposite of the foundation issue where it's being pushed inward. In this case, it's pushing the exterior wall outward. And you have these, we call these facade anchors or wall anchors, just depends on the construction. But these get tied into the floor structure, and they prevent it from bowing outward anymore. But again, if the root cause of the issue is the lintels, they must be addressed as well. We have this. It doesn't occur too often in residential construction, but it depends. If you have spalling of concrete slabs or spalling of concrete walls, concrete beams, balconies. Essentially, when water gets into that concrete and it touches the steel, it corrodes the steel. Just like the lintels, the steel begins to expand. Typically, they say it can expand up to about 10 times its original size. So if you have, most lintels are 1/4 inch thick. That lintel could be, over an inch thick, depending on how long you let it go for. But in this case, it's steel reinforcement inside of concrete, and the force is powerful enough that as that steel expands, spalls the concrete. Usually it starts by delamination. If you tap on it with your flashlight or a hammer, it'll sound hollow. And then if you you don't do anything about it, you keep letting it corrode longer and longer, it will eventually, the concrete will fall off. If you drive underneath a lot of bridges, you'll probably see something like this. And it's not fixed by just parging some cement over it. It's not fixed by caulking. You actually have to cut out the concrete, and depending on the condition of the reinforcement, you actually have to replace some of it. This is just kind of a general detail of what a partial depth concrete repair looks like. You have to essentially saw cut it, chip out some of that concrete, and you have to get behind that steel reinforcement. There's minimum requirements of how much of that new concrete needs to get around that steel reinforcement so it doesn't just flake off like a patch. Yep.
So just a question on these slabs under tension. Do they have a problem with rusting over time and decaying and causing issues? Because as I understand it, that could lead to a serious issue if that were the case.
So if it's a structural slab, then yes. If it's a slab on grade, basement foundation, you might have some welded wire mesh in there. It's not typically enough to cause a lot of damage. But if it's a floating slab, or let's say you have a garage slab that has a room below it, then that would be a structural slab. And yeah, if it's, let's say, open court setup where it's open to the elements and water is able to get in there and cause damage, then yeah. And foundation walls as well. The newer poured concrete foundation walls typically have steel reinforcement in them. And if water is getting into a crack and touching that steel reinforcement, it can begin to damage the wall. So this is kind of an example of, say, a foundation wall that's having some spalling or delamination. Here would be an example of a slab, a structural slab, same thing, except this would, in this case, would be a full depth repair where, depending on the thickness of the slab, usually if it's more than, if you have to remove about more than half the thickness of the concrete, you have to do a full depth repair as opposed to a partial repair. So this is a little bit more in terms of condominiums, apartment buildings, some older construction. You'll probably see some of this, where you might be in the basement of a condominium building or an apartment building where all the floors are concrete, and you may see this. So epoxy injection. So if you have cracks in foundation walls, you don't want that water getting in the wall and touching that steel reinforcement for the same reasons as the lintels and the lintels and the reinforcement. And so injecting it, not just caulking the surface, but actually injecting it. Typically we recommend epoxy because it's a structural repair as well. But depending on the size of the crack, you can also use polyurethane if there's expensive polyurethanes. It really depends on what you're trying to achieve. But essentially, ideally, you're filling up the full thickness of the wall. Usually, most foundation walls are 8 inches thick. You don't just want to put a surface seal on it. You want to fill the whole thickness of the wall and any void around it with epoxy or polyurethane, depending on what you're trying to accomplish. In addition to that, if the crack, our standard is if the crack is more than 1/16 of an inch wide, we recommend putting in what we call stitches. They're carbon fiber stitches. They get epoxied in at the same time you would epoxy inject the wall, and it prevents the wall from shearing or sliding in any direction, and it puts the design strength. It makes the wall stronger at that area than it was before. And if it's a settlement related issue, it's not going to prevent settlement from happening, but the crack's not going to open up again. If the structure settles, it will crack somewhere else, and that's a different problem to address. It's an example of what they look like. They're typically installed every 10 inches. Not the prettiest thing, a little Frankensteinish, but ideally you're covering it with something, epoxy coating or carpet flooring. Beams and columns. So we have an example here of, this is a house in Vienna where it was a new home, but when they installed the this rear exterior support that supports this overhang, they installed it too close to the foundation, and they installed the footing in the fill and the backfill of the home. So they built the house, built the foundation. When they backfilled it, they probably dug out 6 to 8 feet to build it for whatever reason, and then they installed a footing on that, and that's going to settle a lot. I mean, that might settle a foot in a couple years. And there was all sorts of symptoms of this. As you can see, the actual upper level floor of the home was beginning to lean and slope. If you look at the decking here, you can see the deck is smiling a little bit. It has that sagging effect to it. And here you can see that column, the laser starts at 2 1/4. So here it's settled about 2 1/4 more inches than the surrounding areas. Pictures usually hide this stuff pretty well. So if you can see it in a picture, it's pretty bad. So the building officials typically require, if you're building a foundation within 5 feet of a structure, the bottom face of that footing has to be the same elevation as that structure. So you can't just build, you can't put a column in the ground 4 feet from your basement foundation and just dig it down to the frost depth of 24 or 30 inches. You need to go to wherever your basement foundation is. So if you're going to install a deck, the footing of that deck needs to be down as deep as the adjacent structure, if it's within 5 feet. If it's otherwise you're installing a footing in the fill and it's going to settle quite a bit. An inspector could come out, they could probe the ground, and it may seem okay, but after it goes through iterations of rain and the elements, that soil will tend to settle quite a bit. If you've ever dug a hole and then backfilled the hole, and then you come back a month later, there's a big divot in the ground where that soil has settled.
But can't that be corrected or addressed by proper tamping and maybe gravel and tamping and gravel?
It can, but generally speaking, home builders are not going to do that unless they have a really good reason to. This would have been a really good reason to do that, but they weren't thinking, I suppose. I don't know. It just, no one had thought about it. They could have probably just moved the column out maybe 2 more feet or 3 more feet and not had the issue. But it happened. In this particular case, your options are either you move the column to an area that's suitable to support it. You dig down, in this case, about 9 feet to the bottom of the footing, of the basement footing next to it, to get to that same elevation, which would be a lot of work to do that, especially with there's a deck already on top of it. Or what we came up with was to actually install a helical pier that actually screwed down, and it just needed to meet that elevation. So the pier obviously had a torque requirement, needed to meet the load, but then it also had a depth requirement of, let's just say, 10 feet or so. It had to at a minimum get down to that virgin soil that was not affected by the basement foundation construction. Yep.
Wait for my mic, there it is. Okay, so with these front porches, especially in older homes where they've got the slab and then they've got the columns to support the overhang, and it's kind of doing this bowl shape with cracks and everything around it right up to the front door. When they ask me, why does this happen? I usually tell them, I'm not sure, but it could be that they built this slab on top of the fill. Right? After they cut the hole or made the hole for the house. They used to put trash and everything else around the building site in here. They put the dirt on top, and then they did this slab, which is now obviously subject to the gravity, et cetera. And then I tell them to get an engineer because I don't know how to fix it. I can't tell them how to fix it. But then I get a phone call that says the contractor's here. I'm like, the engineer? No, the contractor. Right? They skip the engineer part and go right to a contractor. And they said that they were going to squirt some foam, some structural foam underneath to raise it up. I'm like, I wouldn't do that. I would go the engineer route first because I don't know. If you're asking me a question I don't know the answer to. So how would you address that type of a situation if you got called out?
So it varies. I mean, one example would be if is the porch supporting the roof or the house or something else, or is it just a slab that's not
Just the
supporting
overhang
anything?
Of itself.
And so, and you'll notice that in new construction, a lot of the basement foundations, they bump out for the stoop,
Yeah.
so that the footing is the same depth as the rest of the foundation. But it varies. I mean, if the home is 50 years old and the stoop has settled an inch, then structural polyurethane, I mean, it doesn't seem like there's been movement for a long time. Maybe that's an adequate repair. But the structural polyurethane foam is not typically used to support anything other than a slab or maybe a thickened slab or some steps. It's not meant to support a structure above it as well. And usually it's pretty light though. So, I mean, that is a potential way to do it. Outside of that, I mean, you could install helical piers. That would definitely be an option. Push piers, it's going to be too light to install push piers probably because it relies on the weight of the structure to push them into the ground. But helical piers would be definitely typically the recommended solution. But it can be pretty expensive to do that too. So.
Is there a lifespan for helical piers?
Most manufacturers warranty them for about 30 years. I've talked to some of the manufacturers that have done tests where they see how they corrode in the ground over a long period of time. And it's a very, very long time. I mean, I've heard some numbers, 700, obviously they can't test a pier for 500 years, at least easily. But I've heard numbers from 700 to 1,000 years is what they project how long the pier would last in the ground, assuming there's not any types of corrosion or chemicals or something in the ground that's going to deteriorate it faster. But in normal galvanized steel, very, very long time.
So what would the failure mode be without the corrosion you were saying?
Well, the failure mode would be the corrosion, but that's basically how long it would take for the steel to corrode enough that there wouldn't be enough section there to support the load above. And since in the case of, say, most piers are installed with at least a safety factor of 2, so how long would it take a hot dip galvanized steel member in the ground to lose, say, half of its section loss? Yeah, lose half of its section. And in the ground, there's not a lot of air. If you drive by a bridge and you see where the water line meets the bridge, and it's getting wet, and then it's drying, it's oxidizing, it's wet, dry. That's typically going to deteriorate much faster than something that's deep in the ground. If you look at a lot of the bridges in this area, I mean, they'll run piles with no galvanization at all, just raw steel piles in the ground. And I believe most of those designs are at least 75 years. So
Oxidization requires oxygen, and there's not much oxygen below grade.
Yep. Yeah. Here we have some columns in a crawl space that are settling. Obviously, the top two, the bottom part of the column is settling, and there's a space there. Same with the bottom two as well. You can only install so many shims until someone decides to do the right thing and just replace it with a proper column or pier with a proper footing of some sort that's not going to continue to settle. But in terms of a temporary solution, shims will work. In terms of beams, so the purpose of a beam is to span, is to support something and span it from 2 supports, one support to another. In residential construction, pretty much all your beams are simple span beams usually, and there's a continuous load on top, like here in this diagram. And this is the formula for the bending moment of a beam. And it's the uniform load times the length squared over 8. That's the bending moment. That's how much bending stress is on that beam. And you'll notice that the length is squared. The length is the key factor there. It makes much more of a difference than the actual uniform load. And to give you an example of this, you have two 8-foot long spans here, and then you remove the center support, which we see sometimes. All of a sudden that 8-foot span becomes a 16-foot span. So you've increased the span length by 100%, but you've actually increased the bending moment by 300% on that beam. So you know, every unit or foot you make that span longer, you are increasing the stress on that beam exponentially. Here's another example here. If you back one, you have an 8-foot span and you just add 2 feet to it, and now you make it a 10-foot span. You've increased the span length by 25%, but you've increased the bending moment by more than half. So it's not recommended to remove load-bearing supports without consulting with an engineer first. Here's an example of exactly that. The column wasn't needed. I don't know how he or she came up with that assessment, but so they removed the column, put in a nice big 16-foot wide garage door, and it turned out to only be supported by a double 2x10. And so not only was the floor above it in the house sagging, but you could see from the outside the header was sagging. And then they started to get these cracks in their garage floor as well, because instead of having 3 supports with columns and footings underneath of them, now that entire load is, instead of being 33%, 33%, it's now 50%, 50%. And the footing below here wasn't designed to support that much load. And in this case, you can see it's supporting a floor, 2 floors above it, plus a roof load. So it's a pretty serious issue. We temporarily braced it. Obviously came up with the design first, temporarily braced it, and then reinforced the footings and installed I think it was about a 10-inch steel beam there to support it. The load was something like the double 2x10s were only rated for like 15% of what the factored load was. Luckily, wood it's very forgiving, so it's not typically just going to snap in half like a toothpick. It will bend quite a bit first, but it's a serious issue. Yep.
So you just said something interesting that an engineer like yourself would understand, but how did you determine that it was the 2x10 combo was only 15% of what's required?
So we calculated it. Yeah, so we calculated the loads and what the new beam would need to support, and then we calculated that based on what was there, and that's how we came with that determination.
You just make some assumptions as far as the weight. Are there tables that you can go to in structural books that say, hey, if you have a 2-story with everything, this is what the weight would be in the middle of this span?
Yeah, exactly that. In terms of dead loads, there's standard floor dead loads for certain size joists, subfloor types of flooring. Typical dead loads for a residential floor is between 10 to 17 pounds per square foot. In terms of live load, well, and then the same with roofs as well, attics. And then in terms of live loads, typical residential live loads are 40 pounds per square foot. Sleeping areas can be less depending on the municipality. If you have an attic, is it an attic with storage or without storage? There's different factors that the building code specifies. And then the same with the roof. Is the roof, the slope of the roof can affect it, as well as the type of roof. Is it asphalt shingles, clay, cedar? They all have different weights to them. And yeah, I mean, if you think about if you have a flat roof and we get 3 feet of snow, that's a lot of weight on that roof. If you have a steep roof, you don't have, snow, it's not anticipated that too much snow would build up on it. And in a newer house like this, it's a trussed roof. So half the roof goes to the back wall, half the roof goes to the front wall usually. And if, let's say, the house is 30 feet deep, you have roughly 15 feet, half that roof load coming to this front wall. So in this one, you have, so if you look in the top left picture there, you have a roof load. You can see there's dormers, that's a master bedroom up there. So you have a floor load. And then on the main level, you also have another floor load. Plus you have an exterior facade load, which, in this case, it's vinyl siding, a timber framed wall with vinyl siding. It's light. It's usually 6 to 7 pounds per square foot. But you add all these things together, it's a lot of weight.
So essentially you replace the wood beam with a steel beam?
Exactly.
But also reinforce those.
Yeah. Yep. Yeah, so this picture down here with the crack, if you look down here at the bottom right, concrete was removed. We doweled in some steel reinforcement into the existing footings and then poured a larger footing to compensate for the additional load. Here's another similar example. In this case, the owner had a 12-foot wide door. This is out in Reston. And he noticed he thought the door was sagging a little bit. The door wouldn't open all that well. So we came out there and we observed that. We put a laser on it. We could see how it sagged down in the middle. We went upstairs above this, and the floor above sagged, or sloped, I should say, about 1.5 inches towards the same area. So we're seeing multiple signs, multiple symptoms of the same issue. And then we had him remove a little bit of drywall. Here you can see the difference with the laser between at the ends versus at the center. And we have him remove some drywall, and similar to the garage issue, it was a double, in this case, 2x12. This one was supporting even less, but still this double 2x12 was rated for about 300 pounds per linear foot. The service load, the actual load of what's there, dead load plus live load, should have been rated for 1,100 pounds per linear foot. So again, luckily wood is very forgiving. It's a very serious problem, but luckily it's just needed to be fixed, and it gave the warning signs that something was going on, and the homeowner noticed and did the right thing. In addition to this, whoever installed this 12-foot wide opening, they actually, one of the columns they installed right above a window well, or a basement window in the basement, which was not properly rated for that. They just installed it right on top of the window. So that could have been much worse. In this case, the window was under a deck. The owner didn't care. The easiest thing to do was to install some rebar and just terminate the window well and fill it in with grout, concrete. Floor joists and trusses. So some plumbers don't like floor joists, and in my opinion, at least, I like to say that the foundation of your home, or the structural members of the home, should be of the highest importance. Some people disagree with that, obviously, or just don't care. But you can see here that someone put a large notch in this joist, and I guess they hadn't heard of a Sawzall or multi-tool yet. They used a drill, and you can see how much of this joist was notched out here. And then in the other case, they decided to install a sink, I guess, above it, some sort of plumbing, and the P-trap was a little more important than the floor joist. So these are serious issues. The building code actually tells you where and how you can alter a joist, and it depends on where as well. So just something to be aware of. If you're in the outside 2/3, you're able to notch it, but there's limits. If you're on the inside or the middle third, you can bore holes in it at about mid-height, but you cannot notch the top or bottom of the joist. Those are the areas that are in the most tension or compression. The areas closer to the bearings at the ends are just in shear, so it's a little bit more forgiving. But yep, this is straight out of the building code. If you're dealing with truss joists or eye joists, typically the manufacturer will specify the same thing, where and how you can alter a joist. So that's a little bit different, but usually you can find out who the manufacturer is, and you can go online and find out, what's allowed and what's not allowed. Here's an example of in a crawl space. You've probably seen a lot of the supplemental bracing. The floor joist span from the left wall to the right wall, or a wall to a beam, and say the span length is 20 feet or 12 feet, whatever it might be. If you split it in half, it's a very effective way of reducing a lot of stress on the joists. Going back to our examples of the bending moments earlier, if you have a joist that is spanning 20 feet and then you split that in half, you've reduced that stress on that joist by a lot. There's some. So it depends. If it's on the exterior, it has to go down to the frost depth, which in this area right here, it's 24 inches. If you go up to Minnesota, it might be 6 feet. But so in the middle of the winter, the ground can freeze, and just like a can in the freezer can not explode, but it will expand, and it can cause the structure to heave if the footing isn't deep enough. If you're in a crawl space, it's sheltered. You typically have perimeter walls, and ideally conditioned space above it. It stays much warmer, so typically about a foot. So this is kind of how they look. You've probably seen where someone has stacked some cinder blocks below something like this. Obviously, that's temporary and not code compliant. The same with the lolly columns that have the bolts going through them that are not code compliant. They're for temporary bracing. It's only temporary support. So here we have an example of that. You have a 14-foot long span, and let's say the joists are sagging, and the homeowner's concerned with it, and that it's noticeable. If you put a supplemental support in the middle, I say supplemental meaning it wasn't originally there, it's just additional. Still has to meet the code, but at least in this area, it still has to meet the code. Still has to meet the code, but you're now dividing the span length in half. So it's going from 14 feet to 7 feet. You've decreased the span length by 50%, but you've decreased the bending moment, the stress on that joist or beam could be either by 75%.
We're about 20 minutes away from.
Okay. Here's an example. In this case, there's your 12 inches in a crawl space. If it was on the exterior, it would need to be deeper in this area. This is a crawl space example, and then we have a more of a basement example, both supporting, in this case, steel beams. Floor joist sistering. There are standards for sistering floor joists. It's not just put a floor joist up and put some nails in it. There are, it should be verified by an engineer, technically should have a permit as well. Depending on where the defect in that floor joist is, there's typically overlap requirements for how much you need to overlap, but it also depends on where the defect is. In this case, the defect's at mid-span. This is a full-length sister, but if we look at, this is a partial length sister, let's say there's mechanicals and HVAC system in the way. You don't necessarily have to do a full length, but it has to meet a certain development length to transfer that load back to the joist. Same thing, if your defect is at the bearing, you don't have to do a full length sister necessarily. But you have to be able to develop that strength back into the joist to a good solid part of the joist that's going to be able to handle the loads. This is an example of, it's similar to sistering, but we call it flitch plating. If you have typically not joist, but with beams, you have timber beams and they're sagging or there's some issue with them, or you're adding a load to them, you can sandwich them with steel plates, or in this case, a steel channel. You through bolt them and it can add a lot of capacity to the beam. Here we have some truss floor joists here. Again, our favorite plumber chose to, he cared more about the P-trap than he did the floor joist. So he cut the floor joist. That's a serious issue. Anytime you're dealing with a truss, it's a non-redundant structure. So if you cut any member of it, it's going to lose a lot of its capacity. Fortunately, in residential construction, whether it's attic roof trusses or whether it's floor joists, you have a lot of them. So even though by cutting one member of one of them, you're decreasing the capacity of that member by a lot. In this, you probably have 20 more throughout the house. But if you cut several of them, then it's even more serious. The building code prohibits the alteration of trusses without the direction of a professional engineer. So you can't just cut these and then throw a new attic staircase in. You can't just cut them for a P-trap or anything else. It's a serious issue. These trusses, they get inspected at the factory. They generally don't get inspected by the building inspector when the home or building is being built. All the official or all the inspector comes out to look at is to make sure that they have a certification. So they get inspected in the factory. When they get shipped, you got your cert. All the inspector wants to see is that they're installed like they were supposed to be and they have the cert, they're good. Now, if let's say they're damaged during that delivery process or craning them in, then a professional engineer has to design a repair before they can be installed.
What is the authority if it's not a truss, but rafters and rafter ties that can be compromised in an attic in terms of a repair? Somebody cut through either a rafter or a rafter tie.
So if it's a rafter, that would be looked at the same as a floor joist or a ceiling joist.
Mhm.
So it could be sistered.
Okay.
Whereas if you're talking about truss floor joists, it's a pretty detailed process to design the repair, and it typically involves sandwiching the trusses with plywood, certain nail pattern, and gluing it.
Are framing contractors knowledgeable enough or skilled enough to devise a repair?
For a truss,
Not a truss.
for say a rafter or
Yeah.
a floor joist,
Yeah.
I would generally say so. I wouldn't necessarily recommend that, but I would generally say so. I mean, at the end of the day, you could do a full length sister, and now it's you've essentially replaced that member. So I mean, that would be generally an adequate repair as long as moving the structural member over 1.5 inches or so doesn't cause an issue.
So from an inspection perspective, if you're in an attic, there's a truss that's been cut and sistered, you would expect to see there in the attic posted or somewhere an engineer's sign off stamp like this was actually done by a professional engineer.
In a perfect world, yes. Yeah, exactly. And if you okay.
Sorry, the area where we see a lot of that as an issue is new home construction.
Yep.
Especially townhomes and units. That last one that was the bottom of the pile when they throw them in, and then they'd throw a couple sister boards up there, and then the project manager sister arguing with you. No, it's fine. I'm like, and he's a structural engineer, period.
Mhm.
No, it's fine. Like
Mhm.
this, we see that a lot, but so in that, according to this, doesn't matter, new home or old home, it still has to have the professional engineer on it, correct?
Yep, that's what the building code specifies. And if you walk into a home and you know that your roof trusses are, say, front to back, and you walk in and you see that the attic staircase is left to right, usually they're about 55 inches or so, and the trusses are spaced at 24 inches usually, they've at least cut one of them. Maybe it's okay, maybe it was modified accordingly, but usually not. Someone just sawzalled it. Here's an issue actually in this area, especially in the Sterling Reston area. There's a lot of homes where the decks were installed with a ledger board over the siding, and just mush that siding together when they tighten the bolts. In this case, there was no flashing either. A little bit of water was getting in there over 30 some years, deteriorated out the whole wall. And the deck had to be temporarily braced, pulled out from the home. The ledger board had to be replaced, and the band board had to be replaced as well. The band board is a structural member. It supports the floor above. So that can be a pretty serious issue if you don't see that flashing. Typically what I would do is I'd go on the inside and put a moisture meter on the wall and see if water might be getting in there. Unless it's, let's say, if the ledger board is installed on a masonry wall, it doesn't always require that flashing, but
Structural.
yeah, it's not brick. Yeah. An example of some columns supporting the front portico of a house, heavily deteriorated, needed to be replaced. Try and speed up here. How much time do I have here?
10 minutes.
10 minutes. Okay. We have, you'll probably see this around a lot of areas, especially with drainage issues, voids below slabs. We were out here, the slab looked a little funny, had kind of a shadow around it. We looked a little bit, kind of got down and looked underneath of it, put a measuring tape in there, it goes under 4 feet. So large void below the slab. It's not structural, but it's not going to get better. At some point, it's going to crack. And this is where the polyurethane foam is an excellent recommendation to fill that void and also compact that soil below to prevent it from happening again. And then, of course, making sure that there's no drainage issues. Grading is good, draining away from the house as well as downspouts. Here's another example of that as well, where there's a large void below a slab. And typically these are often caused by, like I said, drainage issues or also plumbing issues as well. If someone's main drain is broken for years and they don't know about it until it backs up, it causes these voids to occur. You can polyurethane inject them. You can mud jack them as well. We always recommend polyurethane. It's much lighter. You get a lot of pressure on that soil below. The mud jacking, if you have a 4-inch slab and then there's an 8-inch void below it, you've just tripled the weight of the slab on questionable soil. So the polyurethane is very light. Just a better product. Also to install the polyurethane, you're drilling small, about 5/8 inch holes in the slab. Mud jacking, usually it's at least 1 inch or 2. This is an example of what the polyurethane injection looks like. It goes underneath the slab. It can lift it, stabilize it, depending on what your goals are. Especially where you have, it can be done inside of basement foundations, slab on grade foundations, assuming it's not a monolithic slab. Also sidewalks with tripping hazards. So ADA, if it applies to whatever you're inspecting, they deem anything more than 1/4 inch a tripping hazard, or this 2/1 slope here. So something to keep an eye on. And then waterproofing. So we have our exterior drain tile here. It's very important that that drain tile be there. Older homes, many of them don't have it. But if water is accumulating around the foundation, downspouts aren't functioning, and the water is not getting managed and taken away from the house, there's a lot of pressure on that wall. You can have water intrusion issues, and then again, you can have your inward lateral deflection, amongst other issues. This is just a detail that shows how a foundation wall is typically waterproof from the exterior. It's excavated, cleaned, sealed, a membrane is put up, and then you have a drain tile here at the bottom. It's a perforated pipe surrounded by gravel and a filter fabric. And that drain tile must be below the height of that inside slab, otherwise water may come inside the basement. The pipe should also be sloped, and the purpose of the filter fabric is you don't want the soil getting wet, turning to mud, and then draining away, as it can cause other issues. You can do interior waterproofing as well. That's pretty popular these days. If you have a slab on grade garage next to your house, in addition, a deck, if you're going to waterproof that from the exterior, you're going to have to demolish that or dig underneath of it. So a lot of companies recommend interior drainage systems. There's pros and cons. I could go on for a while about that, but one major thing is a lot of those systems don't have a radon seal, and it's open along there that can cause the radon to become an issue. So it's recommended if you're going to go with this type of system that there's a radon seal there. Here's a couple other kinds. You have a gutter system type system that it's not really a true drain tile, it just sits on top of the footing. It's not going to keep water from coming up and touching the slab from below. There's an example of an open cove joint. And then here you have what they call it a track system, where basically it's a baseboard system where if you have a monolithic foundation and you can't trench that slab, the best you can do from the interior is install like a little baseboard gutter that sits on top of the slab to drain that water. It's not preferable, but sometimes you don't have an option. Some basin information. I'm sure you guys have all been probably seen a sump pump with a basin that is all bolted down. Do you guys typically unbolt it, or you don't touch it? Okay, yeah. So we typically would recommend one that has a hinge lid that's also radon sealed, so that way you can actually inspect and service the pump, rather than if there's an issue, it might take an hour to figure out how to get to the pump and test it. Crawl spaces, in terms of the floor joist and deterioration, if there's a lot of moisture in crawl spaces, that can become an issue and damage the floor joists. Encapsulating them is a great idea. It's not required, but it's ideal. And then conditioning it or installing a dehumidifier, if there's no vents, is an excellent idea as well, to make those floor joists last a long time and not decrease their lifespan. I'll just kind of run through this real quick. How much?
You got about 7 minutes left, but for the crawl space, so if you cannot condition it, can the dehumidifier take care of it for you, or does it have to be conditioned when you encapsulate it?
So depending on where you are, the code may be different. If you don't have vents, then I would definitely recommend a dehumidifier. If you have vents, you technically don't have to have a dehumidifier, but you wouldn't want to have both either. You don't want to, if you have vents and a dehumidifier, you don't want to be dehumidifying the outside air.
Yeah, I mean, I'm talking like once it's encapsulated, vents are closed off, right? Because like what we're usually telling people is to make it a conditioned space.
Okay.
But if they can't make it a conditioned space, so their HVAC is on in the attic, their vents come down, they're not getting it down to the crawl space. Does the dehumidifier solve the problem, or do they need to leave it vented?
Yeah, you could go either or. Yeah, I would not recommend encapsulating and closing off the vents and then not conditioning it or putting dehumidifier in, because there's no airflow. Moisture will probably build up. I mean, I've seen some people where they'll have their HVAC contractor, send a duct down in there to condition it. But what's that? Oh yeah.
There's no return.
Okay. Yeah. So differential settlement indicators is kind of a quick review. Interior symptoms, cracks in the walls, obviously, and out of level or sloping floors. Exterior symptoms, cracks in the facade or foundation walls. Sometimes you can't see the foundation walls, it's below grade. Sometimes you might have a vinyl siding facade. You're not really going to see too much cracking in that. And then out of level or sloping mortar joints in the facade. Again, if it's siding, there's not going to be a whole lot to see. In terms of the trend lines with the stair step cracking, giving you an idea of what might be going on. It's not 100%, but it's usually correct. Settlement here. So we have a, let's see, this is a 40-inch high crawl space, and you can see that these numbers here, these are basically elevations or elevation differentials of the floor. You can see most of it's 0, but then at the back left corner, it goes down about 1.5 inches. And so there's some differential settlement going on there. Typically what you would do is you would underpin it with helical piers or push piers, depending on the construction. And generally you want to go, one past the crack is kind of the standard for how to address that. So you don't just address the area that's settled. You can, but it's not recommended. You go one past the crack on each side. Here's an example. You can see it's another 40-inch crawl space, and you can see that the column on the left, it's down about 2 inches. Everything seems to slope towards that area. So does anybody want to guess what's going on here? Column settling, that's right, differential settlement of the footing. Or it could also be the column is failing in some way. Or it could actually also be that the beam itself is sheared in some way that's actually causing it to give this effect. But 99% of the time, differential settlement. And ideally you'd replace with an oversized footing, or you could put a helical pier in as well, depending on the specific conditions. Okay. Here we have a same foundation, crawl space foundation, but the low point is between the two columns. Anybody want to guess what's going on here?
Plumber.
Plumber. So, yeah, very possibly. So because the low point is at the beam and the joist, in this case, rests on the beam, something's happening with that main beam. Some sort of sagging, could be a variety of issues. Termites, plumber. You could, depending on what it is, if it's not defective, if it's just sagging, you could put another support below it, since it's a crawl space. If it's a basement, most people don't want to have another column in the middle of their basement. But yeah, you could add a support, or you could also flitch plate it. You could sister it. Just depends on what exactly the issue is. Let's see here. So you have your same crawl space main beam, and you can see where the low point is here, about midway between the beam and the back wall. Any guesses? The low point is right there.
That's a piano.
Yeah. So, yep, floor joists are sagging. Could be due to a load above it. Or generally the first thing we want to do is look and see, termite damage, plumber, what's going on. If it's just they're old or there's a lot of moisture that's causing them to deflect, then sistering, you could also add the intermediate support with the beam and you could sister it, or you could add a beam with some crawl space jacks there to half the span. Take it from a 13-foot joist span to 6.5. So I'm just going to kind of run through this since we didn't cover this at all, but you can see on the one on the left, there's you have a couple of drain tiles here. You have an exterior drain tile and an interior drain tile. The issue here is that the drain tile is below the bottom plane of the footing. You're not allowed to do that. Building inspectors will flag that as a major issue. And essentially you don't want water draining and saturating that soil below the footing. It'll cause foundation settlement issues and undermining. This one here, this is, so in this case, you have this is a monolithic footing here. The slab and the footing are one. You can see it's built down. And the grade is up against the facade of the building. We see this a lot with townhomes, whether it's the association does it or a neighbor does it. They don't know any better, and then it ends up becoming a problem. So the grade's above the foundation, and we're assuming that's not a timber foundation above there. And the solutions are you lower the grade back to where it used to be, it's where it's up against the masonry foundation or concrete footing here, or you can build a stem wall. You can temporarily brace the building above it, excavate this out, build the stem wall on top of your footing, and then essentially have this new timber wall sitting on top of a stem wall that's say 2 feet high or 3 feet high, whatever it is. I'm sorry?
That stem wall would be blocked.
It could be block or it could be concrete, usually block though. Yeah. It'd be rebarred into the footing. Last couple here. One on the left here, there is no footing. That's a problem. And usually we'll see this maybe carports and things like that, but sometimes some older foundations just didn't install footing at all. And then you have this is just, again, another example of a monolithic footing here where the grade's at the proper height, not touching the timber framing. What's wrong with this detail here? Exactly, the drain tile's too high. The drain tile needs to be below that slab, otherwise you're going to have water sitting in that void, setting up against the foundation wall. No matter how well that foundation wall is sealed or caulked or anything else, at some point the water is going to make its way through. Sealant, like anything else, only lasts so long. If you and you can't excavate it and reseal it every 5 years, at least too easily. So drain tiles above the slab. And that's it. I think I'm out of time. Any questions?
Yeah, how many of those perimeter drains do you think are compromised when they put the utilities in? Or when they backfill? I think most of them are damaged.
Ooh, yeah, I have no idea, but yeah, probably some of them. They have to be inspected.
Yeah, well, they get inspected and then the electrician comes in and cuts it. Or they come in with their machine to backfill and dump a big rock on it, smash it.
Yeah.
Yeah, I mean, I've seen them cut.
Yeah, at the end of the day, I mean, the drain gravel usually does a lot of the work. But yeah, I mean, once it passes the inspection, then who knows? Yeah.
Yeah, a lot of those pipes are compromised.